Here, we will be covering what the sine rule is and when and how it can be used. So the first thing to know is that the sine rule can be used under certain conditions to find the length of a side or an angle of a triangle. So if we take a look at this triangle, we need to be able to label its sides and angles correctly. So you have a little bit of freedom and you can call the sides whatever you'd like from A to C. So let's say I call this side A, this side B, and this side C. Now, being able to label the angles actually has to follow a certain rule. Now, the angles corresponding to each of these sides has to be opposite to the side. So this is angle A, this is angle B, and this is angle C. Now that we're able to label our triangle, let's take a look at the sine rule. So here the sine rule says that sine A over A is equal to sine B over B. And this is also equivalent to A over sine A is equal to B over sine B. When you go through questions, you can decide which one is better for you to use. And it takes a little bit of algebra to show that these two equations are equivalent. So to be able to use the sine rule, we need to actually be missing one of these. So if we take a look at this equation, we could be either missing one of the sides or one of the angles, which means we need a minimum of one side and its corresponding angle. So if we write down the conditions for the sine rule to be applicable, we have we need one side and its corresponding angle. Now, the key word here is corresponding, because we need to have a side and its opposite angle, which is its corresponding angle. And on top of that, we either need one side or one angle. And this could be any side or angle. But the main condition is the first one, where we need one side and its corresponding angle. So let's take a look at an example like this. Here we have two triangles. Let's see if we are able to use the sine rule in either of these triangles. So if we take a look at the first one, we have an angle 46 degrees, so let's call that angle A. Now, if that is angle A, 13 must be side A, because that's its corresponding side. Now, because we have an angle and its corresponding side, that means that is the first condition ticked off. So we are able to use the sine rule as long as we have another side or an angle, which we have here. So the sine rule is applicable here. Now, if we take a look at the second triangle, well, if we call this angle A, then this must be side A. So the first condition has been satisfied, and because we have another angle, the sine rule is applicable here as well. Now, if we take a look at an example where the sine rule is not applicable, so here we see that if we call this angle A, then this must be side A. But we don't know what side A is. And because angle A is the only angle we have, this means that we don't have an angle and its corresponding side. So in this situation, the sine rule is not applicable. Now that we've covered recognition for when to use the sine rule, let's actually see how the sine rule would work. So in this example, we have a triangle where we need to find the angle x. Now, first thing we do, like always, we have to check if the sine rule is applicable. So, if we call the angle that we have angle A, then this must be side A. Because we have an angle and its corresponding side, we're able to use the sine rule. Now keep in mind, because the sine rule says that sine A over A is equal to sine B over B, this means the sine rule can only allow us to find corresponding sides and angles. So, because we have another side of length 15, let's call that side B. This means that we're only able to find its corresponding angle, which happens to be x in this situation. So, because x is what we're looking for, we can now use the sine rule. So let's go ahead and substitute our values into the equation. So we have sine of 32 degrees over 12 is equal to sine of x over 15. Now, if we want to rearrange to find what x is, we need to multiply both sides by 15. So we would get 15 sine 32 over 12 is equal to sine of x. Now, to find what x is, we need to actually take arcsine of both sides. So if we take arcsine of both sides, we get arcsine of everything that we had before. So 15 sine 32 over 12 is equal to x. So here x would be 41.5 degrees. Now let's take a look at this example. So let's see if the sine rule is applicable here. If we call our only known side A, then this must be angle A. Because we have a side and its corresponding angle, the first condition for the sine rule has been satisfied. Now, because we have another angle, 33 degrees, this means that we can use the sine rule. Now remember, the sine rule helps us find corresponding sides or angles, which means because we have the angle 33 degrees, that means we would actually be finding this side over here. But we don't want that side. We want side of length x. So what we would need is this angle. Well, we know that angles in a triangle add up to 180 degrees. So first, we would subtract 33 and 67 from 180. So we have 180 minus 33 minus 67, and that would give us 80 degrees. So this means the missing angle is 80 degrees, which means in our question, to find side length x, we would actually use 80 degrees rather than 33 degrees. So we would call 80 degrees angle B, and this would be side B. Now, in this situation, because we want to find a side length, we would use the formula A over sine A is equal to B over sine B to make it easier for us. So we would have 14 over sine of 67 is equal to x over sine 80. Now to get x on its own, we would multiply both sides by sine 80 to get 14 sine 80 over sine 67. So here x is 15. So that is how we use the sine rule to find missing side lengths or missing angles of any triangle.